Scientists blasted plastic with lasers and turned the plastic into tiny diamonds and a new type of water. We know that plastic contains water. Now, a new research inspired by ice giants like Neptune and Uranus shows lasers can transform a common plastic into tiny diamonds. You can imagine your little plastic water bottles turning into nanodiamonds. And this plastic shocked with high energy laser generate nanodiamonds with a range of technological applications. The image is by Greg Stewart, SLAC National Accelerator Laboratory. Using ultra-powerful lasers, scientists have blasted cheap plastic and transformed it into tiny nanodiamonds, and in doing so, confirmed the existence of an exotic new type of water. That's a first, isn't it? The findings could potentially reveal the existence of diamond rain on ice giants in our solar system and explain why these frigid worlds have such a strange magnetic field. The laser blasted technique could also lead to more earthly applications. Nanodiamonds are diamonds that measure just a few nanometers or billionths of a meter. They have both existed and potential applications such as turning carbon dioxide into other gases and delivering drugs into the body. Study co-author Dominique Krauss, a physicist at Helmholtz Zentrum Dresden-Rosendorf in Germany, told Life Science. Nanodiamonds could also be used as ultra-small, very precise quantum sensors for temperature and magnetic fields, which may result in a plethora of applications. This is what Krauss explained. The technique could also reduce plastic pollution by creating a financial incentive to clear and transform plastics from the ocean, he said. An experiment with cool implications for ice giant planets. For many years, planetary scientists have suspected that diamonds form within the frigid interiors of ice giants such as Neptune and Uranus. If these diamonds do form, they would then rain through the interiors of these frozen worlds. To see whether this process was feasible, the researchers took a sheet of polyethylene terephthalate, or PET plastic. It's a type found in plastic bottles, and used a high-power optical laser found at the Matter in Extreme Conditions instrument in the SLAC National Accelerator Laboratory's LINAC coherent light source to heat the plastic to around 10,000 degrees Fahrenheit or 6,000 degrees Celsius. This created pressures millions of times greater than that of Earth's atmosphere for just billionths of a second. This bone-crushing pressure shocked the plastic, causing the carbon atoms in the plastic to reconfigure into a crystalline structure with hydrogen and oxygen drifting through this lattice. Using a powerful X-ray laser, we could look inside the sample and create movies of the chemical reaction happening there, Krauss said. We saw very efficient formation of nanodiamonds inside the compressed plastic within the time scale of our experiments, just a few nanoseconds. The new research shows that this type of diamond formation may be more common than scientists previously believed, raising the chances that ice giants may sport thick layers of diamonds around their solid cores. The experiment also strongly suggests that at the high temperatures and pressures found in the interiors of such icy worlds, an exotic state of water called superionic water ice emerges. Superionic water ice. This strange form of water allows protons to move through a lattice of oxygen atoms, and if such superionic water exists on ice giants such as Uranus and Neptune, the movement of protons through this exotic type of matter may help generate the peculiar magnetic fields observed on those planets, Krauss explains. Past calculations suggested that the carbon atoms likely found in planetary interiors would make any superionic water that formed there extremely unstable. He said, but our experiments now show that carbon and water are demixing, the unintended separation of the substances in the mixture via diamond formation. Krauss said, this is so isolated water can be present inside the planets which makes the formation of superionic water more likely. And it may soon be possible for a spacecraft to visit our icy neighbors to see whether diamond-rained and exotic water actually exists there. Krauss said, hopefully within the next decade, a new NASA space probe will be launched to Uranus, as just defined as the highest priority by the decadal survey, Krauss said. The findings could also have more commercial applications. Right now, people make nanodiamonds by detonating carbon or blasting larger diamonds to bits with explosives, creating a hodgepodge of different sized diamonds. The new method would be a cleaner way to make diamonds of specific sizes, Krauss said. The team's research was published September 2nd in the journal Science Advances. This is by Robert Lee on Life Science. Please leave your comments. Thank you for your support. My Patreon account, the daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.